Why don't you watch where you're going, you old goat?
I'm sorry, Uncle Darko. I tripped over you. Oh, Uncle Darko. Oh, I'm gonna fall.
I don't give a shit.
I'm gonna fall. Oh.
What the hell you doing?
Oh. Oh, what the hell have you done to me, Uncle Darko? Oh, what did you do to me, Uncle Darko? Hey, hey, Uncle Darko, hey, I didn't see you there. I tripped over you again. I can't get up. I've fallen and I can't get up. How about you? Hey. Good Black Friday afternoon to you all. My Black Friday is spent in my shop today. I just went out for coffee and my breakfast, a sandwich, egg and cheese on a biscuit at Old McDonald's Farm. And I'm working in the shop today. Good afternoon, ladies and gentlemen, and boys and girls, and whatever else came dragging in with you. Welcome to the Blind Tinkerer's Workshop. Today I would like to just go over a few very basic things for you newcomers here getting involved in basic electronics and so forth, and that is checking for ripple on wall warts. Everybody knows what wall warts are. That's these little things that you plug into the wall and you know, get your 9 volts or your 12 volts or whatever it is. Today we're going to be discussing the analog, in other words, the I guess you'd call them the linear type of power supplies, not the switching power supplies. Basically, the switching power supplies are a lot noisier, but we're checking for filtering. Now, I'm going to be going over a few basic things with the oscilloscope and so forth here with you, and how to check if you have an oscilloscope. An easy way to simply check for a ripple coming out of your power supply, your adapter, for whatever you're using it for. Especially the older ones, like these here, go back 25 years or more, and some of them, the capacitors go bad, and that's the common thing with them. They're nothing more than a step-down transformer with a usually a half-wave rectifier and a probably a 2,000 or maybe 1,000 microfarad, somewhere that electrolytic across the output. Very basic, very simple, and what usually fails on them things is the electrolytics. Okay, that's mostly what fails in them. And they're very difficult to break apart. Some come apart easy, others you have to break them all to hell to get it to open. But anyways, this particular one here is a good 25 years old, and it's amazing what the filtering is and how long it'll hold voltage. I will be showing that with my digital meter here, as well as the oscilloscope, which has been calibrated by my good buddy Mike. So this oscilloscope is right on the button. So you can read voltages on an oscilloscope. You don't always need a digital meter, but it's easier on a digital meter because you can actually see the fractions of the voltage, whereas in an oscilloscope it's very difficult to see 1 or 2 volts. You can do it, but it's easier to spot it here. But we're using the oscilloscope to check for ripple, and we're going to go right to the bench now enough of this flapping, because you don't want to listen to me. You want to find out what's going on with the ripple in these power supplies. Alright, I got a Rube Goldberg set up here, and I'm going to set you on a tripod here because I don't like shaky videos, and I'm sure you don't either. Hi, Doug. Okay, seriously now, let's get serious about this because this is serious business here. What I've got here is my Leader LBO 526 60 megahertz oscilloscope set up. We've got the scope set for DC input. We're set at the base. The baseline is down at the bottom. And we're set for 2 volts per division right here. So every division, in other words, every square is 2 volts. So you can actually measure the voltage as long as your oscilloscope has been calibrated. And you make sure your calibration control, here it is right here, make sure it's in the clicked position. Some of them click to the left, some of them click to the right. Every scope is different. So it must be that way, otherwise it'll be off and it will not be calibrated. All right, we're at 2 volts per division. That's where we're going to start out in this case. What I've got here is a Sanyo. This came from an old micro cassette telephone answering machine. It's 25 years old at least. It has excellent filtering capacity. There's no ripple in here that I can detect, and it'll hold the voltage for a very long time unplugged with both this digital meter on and the oscilloscope connected. The oscilloscope, of course, is high impedance, and so is this. So it doesn't pull down much on this. What we're going to do now is we're going to plug this in. We're going to get you set up on a tripod here. I may have to hand hold this at times so I can get you to the different readings here that you need to see. But I'm holding it pretty steady here. None of this. Sorry if I cause you to puke. All right. I got the power pack plugged in. This is my Rube Goldberg. I have to use a little brad here to put it into the center pin here. All right. Okay, what we're getting now unloaded is 12.74 volts. We'll show you that here. Actually 12.72. All right. Now we'll go over to the oscilloscope. First thing, before we put we disconnected the voltage source to the oscilloscope first because we want to set the baseline. In this case, you want to start at the bottom. You don't have to. You can start at every gradial, I should say. You want to start. A lot of times you start in the middle, but you're measuring voltage. I like to start down at the bottom at the first gradial. And we're at 2 volts per division or gradial. And we're at the baseline right here. Okay. So if we were to go up 2 volts, if we had a 2 volt power supply and it was accurate, it would read right here. But we're reading more than that. We're going to put the voltage on it now. It's a little difficult for me to get this in to stay in here because the nail is loose. I got 12.8 volts right now, 12.79. Okay, so you start at the bottom. It says 2, 4, 6, 8, 10, 12, and the fraction thereof. So we're 12.77 on the digital meter, which we'll try to move over, but I'm going to probably knock off my leads doing that. So take my word for it. We're reading 12.76 on the digital meter. But as you can tell, it's very difficult to read fractions of voltage on the oscilloscope. You can do it, but it is very difficult. but you can read voltage on an oscilloscope. What we're concerned with now is ripple. In order to check for ripple, what we want to do is to put it down to AC. We're on AC. If you notice, the line dropped all the way down to the bottom, okay? In other words, we're not reading any AC content at 2 volts per division sensitivity. All right, let's turn the sensitivity up. All right, now we're at 1 volt per division. Now we're at a 0.5 volt per division. We're reading AC now. If we were trying to read DC, we'd be off the scale. All right, we're going to keep going up to the max of, I got to get my magnifying glass out, 5 millivolts per division is what we're reading right here. Okay, now in order to try to read the ripple better, we are going to move up the display so you can see it. As we're going to put it right here, okay? We're concerned with reading alternating current ripple. And as you can plainly see, there's virtually no ripple on that power supply. Okay? We got this thing to the max sensitivity, and we're using an oscilloscope probe ×1. We do not have it set at ×10. We have it set at ×1, which is what you want to have it set at. Okay? Now we can turn the sweep rate down or up. Now, if you want to read a higher frequency, if you're testing a switching power supply, then you'd want to put your sweep rate at a higher rate, because your switching power supplies are going to be having high frequency, not 60 cycle, not 120 cycle. They're going to have very high noise, and what you want to do is to turn this up higher in order to check that. But we're checking what we call a linear power supply now, or I like to call them analog. Okay, so basically we'll set it there. Okay, so right now we're not getting any noticeable ripple in the power supply. All right, now we're going to go back down to 2 volts per division. We're going to go back to DC. But before we do that, let's disconnect the voltage, and we're going to short the input down to ground. We're going to bring our display down at the bottom of the scope right here so we can count our divisions. Now, it doesn't really have to be down here. You can start at any point you want. You can start here and you just count up from here, or you can start here and count up from here. And if you're doing a negative supply, you just simply start wherever you want to put your baseline and go down. So it's a matter of preference, really. But let's go down to the bottom, okay? Because that way we're checking for, this is supposed to be a 9-volt power supply, but unloaded it's putting out 12. Okay, but that's unloaded. Okay, now we're going to plug in the voltage. All right, and we're going to take it off of ground. We'll go to DC. Okay, 2, 4, 6, 8, 10, 12, and a fraction thereof. Now my digital meter shows, hang on, 12.7. I'll move you slowly so you don't get motion sickness. We're still up there. All right, now you keep an eye on the digital meter. I'm going to try to swing you over to the oscilloscope. I'm going to pull the power on this Wart. All right, I'm going to pull the power. All right, Wart's out. Take a look at the digital meter. Now that's some damn good filtering. Okay? Swing you over to the oscilloscope. You notice the oscilloscope is basically in the same spot and just dropped just a hair. So we're still reading on the digital meter 12.3 volts, 2, 4, 6, 8, 10, 12, and a fraction thereof. Okay? So that is a good wall wart. Oldie but goodie. Now, the correct way to check for ripple on any of these wall warts is to put a load resistor across it. But I have to experiment because my math, I'm ashamed of myself. In math, I don't know. I'm stupid when it comes to math. So everything I do in this shop is experimentation. I have an Ohm's Law calculator, and I could use that, of course. But we're not going to put a load across it. We're just going to show what a bad wall wart is versus a good one. And we're going to show that with this. I paid $6.88 for this last month, and it just came in today from eBay. It's a little night vision security camera, and it uses 9 volts, not 12. So that's why I had to dig out an old 9-volt wall wart. I dug out a wall wart to run this on, and it hummed like a banshee, and it wouldn't give any video other than distortion on my monitor up in the corner. I thought the camera was defective, or it was, instead of NTSC format, which is the United States standard for television, I thought it was in the PAL format. So I said, damn it, they sent me a PAL camera. But they didn't. I turned up the audio and it hummed like a banshee. So I knew my power pack was no good. I plugged it into this one, which I just showed you on the screen here, and it ran perfectly. So we have a defective power pack, which is right here. This is the bad one. This is the one that hums like a banshee. I got a note on it, defective. These are things I've had for years. This is 9 volts DC center pin positive, which is what this camera calls for. So I'm going to show you that on the oscilloscope. Before I do, I want to show you that this is still putting out a charge. It's holding a charge. I'll move this slowly here for you. You can see I'm 11.3 volts. And the oscilloscope has dropped 2, 4, 6, 8, 10, 11.3 or thereabouts. It's very hard, like I say, to get the fraction of a volt on this. You can do it by turning this down, or actually the sensitivity up. But right now we're off the screen, so we have to reset it here. But we're not going to do that right now. I'm just showing you how long this wall wart will hold a charge. Granted, your oscilloscope doesn't put a load very much on the wall wart, and neither does the meter, because the meter is 10 mega ohm input impedance. But it just goes to show you how good that wall wart is. All right, I think it's time to short out the input. The wall wart is unplugged still. There we go. Okay. That's the capacitor charging up a little bit. Back up again, the residual charge. 0.2, 0.3 volts. Okay. So we take the load off of it, take the wire out of the wall wart. the meter really should be centered. I might have to, this has not been calibrated, and I got it from eBay, but it's pretty close. But I could probably calibrate that, or I could have my buddy Mike calibrate it, because he's got high quality equipment that he can do all this with. Oh, I could calibrate this with my VTVM also. That's been calibrated by Don, the VTVM that was given to me at the ICO 235 VTVM. I could probably calibrate it. All we got to do is set this back to 0 again. That's an adjustment inside. I'm not too worried about that right now. So now we're going to go put the bad power supply on and show you the ripple. All right, before we put the bad power supply on, we're going to plug in the good one, the one I just got through testing, onto this little camera. It's already plugged in. And it's up on the monitor. Now we got a bright light from this workshop here, so we may have to turn the light off to really see it good. But we're going to plug in the camera now, or the power pack, I should say. Oh, I hate these damn child-resistant caps. They keep spinning out of the way. I got to glue them in place. Okay, the camera's on. And the lens is adjustable for focus. It's supposed to be night vision. I think we'll do is we'll put this like this. Hang on a minute. All right. That's not bad. I got one light on in here, very low light. Now I'm going to set this down. It'll stay there. On top of the power pack here. Turn the volume up on this. Hear the feedback? 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, this camera's got a mic in here. All right. Now, what I'm going to do is to put the bad power pack on there. And you'll hear and see what I got when I first tried the camera out on this bad one right here. So hang on a minute. All right, first thing we're going to do, we're going to unplug the good power pack. The cord is so damn heavy that it's pulling the camera down. It's the only cord I got, heavy duty audio video cables that I had when I had my VCR set up. All right, we're going to unplug this. We're going to plug in the bad one with the real bad ripple. And we don't want to leave this on too long because this will probably damage the camera. Okay. You see what's going on the television up here? Okay. Okay. That is no good. All right, this is 9 volts, DC 400 milliamps, which is way more than what this camera requires. Center pin positive, 9 volts DC output, but it's actually 9 volts ragged AC output. So, what goes bad in these, as I said, mostly the electrolytics, although the rectifiers, the diodes can go bad too, short out or open or whatever. So this will be repaired eventually, but I'm not worried about it now. What I am going to do now is we're going to do the same test with the meter and the oscilloscope. And you're going to see two things. You're going to see a horrible, horrible waveform on this oscilloscope. And you're also going to see that it will not hold the voltage for any length of time at all when it's unplugged off the wall. Before we get started, you notice there's nothing up there. This is the good one. We're going to plug it in. All right. Now I got the volume up. Although you don't hear the hum, you just hear feedback. You can see the camera's pointed at the ceiling here, all right? Now, if I pull this out, the camera's going to go out instantly because the camera's drawing power off of this. It won't hold the voltage like it showed on the oscilloscope because the camera is pulling it's using up power out of here. And I'll show you. Immediately goes out. So the reason I ran that test is just to check the output waveform, which there shouldn't be any because it would be ripple if it had a waveform, but also to see how good the filtering is, and the filtering is excellent in this one, and it holds a charge for a very long time until you put a load on it, which is normal. That's what you're supposed to have. All right, now we're going to go run the same test using the bad power pack here. All right, 8.03 volts, so it's low in voltage. All right, let's take a look at the scope here. Isn't that lovely? Now we're reading DC here. We're on the DC scale. We shouldn't be seeing any of that but a straight line. This is the AC. That's the AC. We're at a half a volt per division, but we're not set to the baseline yet, so let's do that. We get the brightness up a little bit higher. Let's set that down there. Okay. All right. Well, we're reading AC, so I really should be in the center. All right. It should be in the center here. Okay. There we are. That's pretty nasty looking, isn't it? Let's get the intensity up. That's pretty nasty looking. All right. We got an electrolytic here, 2200 microfarad at 50 volts. We're going to put it across it. Cleaned it right out. See that? We'll take the capacitor off. Put it on. Take it off. All right, we don't want to leave this intensity up too high. Always keep your intensity down on the oscilloscope. Never, all right, we'll put the magnification back to normal here. Never run your intensity high on the oscilloscope, especially when you got a static waveform on here. Static waveform means nothing's moving. All right, so as we set up the volts per division, and we are on AC here, we are showing a lot of garbage in here. All right. So this power pack is no good. Now, let's go back to DC. We'll put the line back down to the base. The baseline down here, flip it to DC, which is supposed to be DC, but you can see. And we'll pull the power pack. Instant drop. On the meter, it's 0. So, that's basically how you check a wall wart. But they really should be under load. And a wall wart, we're talking about the linear, what they call a linear supply. In other words, the ones with a transformer in them, a rectifier or two, depending on whether it's half wave or full wave, they do vary. And an electrolytic, usually only one in these things. So I like the old style. I don't like the switching ones. They generate a lot of noise. So if you ever get any of these, they're easy to repair. The hardest part is opening them up and usually you bust the case. I'm never successful in opening these things up. I've seen guys open them like there's nothing to it. Me, I end up destroying the case trying to open it with screwdriver gouges in it and everything else. Sometimes you have to take a Dremel tool and saw them open at the seam. But if you can get them open, they're very easy to repair. I've repaired a few of them in my time. The electrolytic basically is a simple electrolytic, usually 25 volts. Is sufficient working voltage, and at least 1,500 to 2,000 microfarad. A little larger if you can get it in there physically. So this happens to be a 2,200 microfarad that I was connecting up through here on my Rube Goldberg setup here. Everything I do in this shop is Rube Goldberg. Well, I hope this helps you out. This is the Blind Tinkerer. Thanking you all for stopping by, and we hope that we can do another one of these videos in the future. Thank you for watching. Have a good day.